So, get this. What if I told you the answer to one of the biggest questions in physics, what really happened in the first few moments of the universe, wasn't hidden in some crazy complex equation, but was actually inside a beautiful geometric object? And no, this isn't science fiction. Physicists have found a real thing they're calling the Cosmohedron, and it might just be the key to understanding how everything began.
You see, the central challenge for cosmologists is a massive one. To really understand the universe's birth, they have to figure out the physics of what was going on right after the Big Bang. And they do this by looking at the oldest light in the universe, searching for these tiny, faint patterns, echoes from that very first instant. But trying to calculate what those echoes should look like, well, to put it mildly, it's been an absolute nightmare.
So, here's our game plan. We're going to see how we get from that cosmic mess to a surprisingly clean answer. We'll start with those faint cosmic echoes, and then we're going to wade through the mathematical swamp that had physicists stumped for decades. After that, we'll get to the big reveal, this elegant new shape that just cuts through all the noise. We'll see how physics can literally become geometry, and finally, we'll unpack why this discovery might just change our whole picture of reality.
All right, first up, what are scientists actually looking for in those ancient echoes? This isn't just a random search in the dark. They are hunting for very specific clues that are hidden in the oldest light we can see, the cosmic microwave background radiation. These clues have a name. They're called cosmological correlators. And honestly, the best way to think of them is as the universe's very first fingerprints. They're these incredibly faint patterns, like tiny ripples in space-time, left over from that initial moment of creation. So the idea is, if we can accurately map these fingerprints, we can basically decode the DNA of the universe's birth. Okay, so we know what they're looking for, but how in the world do you calculate what those fingerprints are supposed to look like? For decades, physicists have had a tool for this, but it turns out it was kind of the wrong tool for the job, or at least a mind-bogglingly inefficient one. And this brings us right to the heart of our story. It's a battle between two completely different approaches. You've got the old, messy, complicated way, using something called Feynman diagrams. And then you have the new, unbelievably elegant way, which involves a single, perfect object, the Cosmohedron. Now, don't get me wrong, Feynman diagrams are a brilliant invention. Each one of these little drawings represents a single possible way particles could have interacted in the early universe. To get the full picture, you just have to draw every single possible diagram for an event, do the math for each one, and then add it all up. Sounds simple enough, right? Yeah, not even close. This is where things get really weird. As one of the researchers, Francisco Vazan, explained, physicists started noticing something bizarre. They do these gigantic, monstrous calculations expecting pages and pages of mathematical terms, but at the very end, most of them would just magically cancel each other out, leaving a ridiculously simple answer. It was a huge hint that the universe was trying to tell them something, that all that complexity was hiding a much simpler truth. And just to give you a sense of scale here, calculating the interactions for just 9 particles using the old method generates over 78,000 mathematical terms. 78,000. And remember, almost all of that incredible complexity just poof, vanishes in the final result. You just knew there had to be a better way. And this, right here, is where the breakthrough happens. After seeing all this hidden simplicity over and over again, the researchers started to ask a pretty radical question. What if you didn't need to calculate 78,000 terms at all? What if you could just skip it? What if the simple final answer wasn't something you calculated, but something you could just find? What if the answer to all that physics was actually encoded in the geometry of a single shape? And that's when they found it. Meet the Cosmohedron. It's this newly discovered geometric object that does exactly what they were hoping for. Think of it like this. Instead of giving you a 1,000-page recipe book with messy instructions, that's the Feynman diagrams, the Cosmohedron just hands you the finished cake. All those thousands of calculations are already baked into the facets and edges and volume of this one single shape. Okay, so I know what you might be thinking. How is this even possible? How can a physical shape be a calculation? It sounds a little like magic, but it's really about a fundamental shift in perspective. It's really all about switching languages. The old language of Feynman diagrams is algebra. You're just summing up term after term after term. But the new language of the Cosmohedron, well, it's geometry.
It completely replaces the tedious act of adding thousands of numbers with the much more elegant act of just seeing a structure. So how do you actually build this thing? Well, stick with me here. The basic idea is amazing. You start by representing a physical process, like particles bouncing off each other, as a simple polygon. Then, every possible way those particles can interact becomes a smaller shape, a subpolygon, nested inside the bigger one. Here's the cool part. The fundamental laws of physics become the rules of geometry that tell you how these little shapes are allowed to fit together. And when you combine all the valid geometric pieces, you don't get an equation. You build a single, unified object, the Cosmohedron. I mean, let's just put these two methods side by side because the difference is just wild. With Feynman diagrams, you're buried in paperwork, summing up thousands of complex terms to get your answer. With the Cosmohedron, you just find the volume of this one geometric object, and you get the exact same result. It's all there. The entire calculation is the shape itself. Now, you might be thinking this is just a really clever mathematical shortcut for physicists, and it is. But the existence of the Cosmohedron points to something so much deeper, a fundamental truth about the nature of our universe. So what's the big takeaway here? Well, first, the obvious one. This massively simplifies our ability to calculate what was happening at the Big Bang. But more profoundly, it reveals that there's this hidden geometric order underneath the seeming chaos of particle physics. It's like we've been given a powerful new language to describe reality. And by translating physics into geometry, who knows, it might even help us find new, hidden connections between the fundamental forces of nature. The discovery of the Cosmohedron really suggests that maybe space-time and the laws of physics aren't just described by geometry, they might literally be geometry at their deepest level. And that leaves us with a pretty mind-bending final thought. What other profound secrets of our universe aren't hidden in some ridiculously complex equation, but are just sitting there inside a simple shape, waiting for us to discover them?